Alright, so here we have a basketball launcher, aka catapult, and a group of degree students came together and built it. It was designed to score this basketball into a hoop at a certain distance away. So basically we made the frame to the bottom, which was 50 centimeters by 150 centimeters, and we reinforced it with these pieces of wood here so that it will be strong, and we calculated a height which will be total of 0.825 meters, and we basically took the half of this here to find the length of our throwing arm. We used fish gun rubber as our spring, and unfortunately our basket that we designed properly broke out due to this hitting impact here, and we had to make a substitution for this here. So basically we just lock it back, pull it back, and we use our locking mechanism here. We hold it in, make sure everything line up, and when it's ready to fire, we pull it out. So we have here a diagram setting up as how we would launch the basketball to score in a hoop 6 meters away. So the basketball will be fixed at 45 degrees and it will shoot and score in that basket. To find VO, we had VOX and VOY. As you can see here, we use equations of kinematics and we use the equation of motion, where X is the distance, Y is the basket height, YO is the release height, and VO is the initial velocity. So we wanted to find the time in A. So VOY from SOHCAHTOA to A, we found that it was equal to VO sine 45 degrees, which is equal to 0.707 VO, and it's the same as it follows here for VOX. So hence, from the kinematic equation, X was equal to this. So where XO and a half AT squared was equal to 0, and we found that X equals to VOXT. We manipulated the formula and we found that T was equal to X and VOX, and X is the distance from the basket, which was 6 meters, and we found that VOX was equal to 0.707 VO. So following now, we substituted T into this equation, the other kinematic, and we found a value for VO. So the height here was 0.825 meters, so that fit in here, and we substitute all our values here. We did our basic maths calculations and we found a value for VO, 8.55 meters per second. As we can recall, hence VOY and VOX was equal to this, and we found this value here. Therefore, we was able to substitute it into our T equation, which was X over VOX, which we just found VOX 6.05 here. We put in our distance of VOX and we found that it took 0.99 seconds to reach the basket. Continuing here, since distance was equal to speed by time, we was able to find the maximum distance, which we use the velocity that we found VO multiplied by the time, which we just found, which was 8.55 multiplied by 0.99, and we found 8.46 meters was the maximum distance that the catapult could have reached with that distance. So now we have to find the acceleration, which we use our equation of motion, S equals ut plus half at squared. The initial velocity, which was u, was 0, so that cancel off, and we rearranged the formula to find that A was equal to 2s upon t squared, which we then found that was equal to 12.24 meters per second squared. Here we had the forces generated, and we used Newton's second law, which was the sum of all the forces is equal to mass by x double dot, which is equal to the mass by v dot, which is equal to mass by acceleration. We plugged in our values and we found the forces generated was 3.464 newtons. Finally here, we wanted to find the speed, so the distance was equal to speed by time. We arranged and make speed the subject, and we found that speed was equal to 6.061 meters per second.